Hi everyone, welcome to today's Overleaf Intro Part 3 webinar. I'm just going to allow a minute or two for more people to join us, but if you are able to see my screen, if you would like to follow along today, there are some instructions for how to get set up with the test project that we are going to be making some edits to and changes to today. So I'll be back with you in a minute or so. Okay, it looks like we've had some more people join. So thanks once again for joining us today on today's Intro to Overleaf Part 3. Today I'd like to go through a mix of topics, both LaTeX related topics and also some topics specific to the Overleaf online editor itself. So just a quick outline of what we'd like to cover today. You can see at the bottom of my screen on the PDF preview. I'd like to cover some information about document structure and cross-referencing. Also a little bit about math typesetting with LaTeX. Some information about more complex tables and figures that you might run into when editing documents using Overleaf. And towards the end, I'd like to cover some of the more advanced features of Overleaf with adding references to your projects and also using the templates that we have available on Overleaf. If you take a look in the chat, my colleague Ryan has shared a read-only link to this project. So if you would like to follow along, you can open that project and create a copy of the project. You do that by clicking the Overleaf menu in the upper left and then choosing Copy Project. If we do have some time to go through a more advanced topic, I'm going to put a poll on the screen. If you'd like to see one of these topics covered during the webinar today, please make your vote, and if we have some extra time, we can dive a little deeper into one of those topics. And again, if you would like to follow along, the link to the example project is in the chat feature of GoToWebinar. I'm just going to allow a little bit of time for those poll responses to come in. Okay, thanks everyone for voting. I'll just share the results very quickly here. It looks like the most votes or for tips and tricks for customizing the compilation process on Overleaf. So if we have some extra time at the end, we can cover that, and I'll also open up to more general Q&A as well. So thanks everyone for voting. All right, returning to our Overleaf project. Like I mentioned, if you'd like to follow along, you can visit the read-only project link and create a copy of the project. So let's get started. The first topic I'd like to cover is document structure. And this is one of the great features of LaTeX is it allows you to separate the structure and the content of your document from the styling of the document. So instead of saying I want a section heading, it should be 18-point font, bold, and numbered. In LaTeX, you can just say \section and then the name of the section. And all of the styling of that section heading is controlled by what's known as the document class, which in this case is article. There are other built-in document classes like book or report, and lots of other custom document classes for, say, a journal article or a book for a specific publisher might have their own special book class. And all of the styling is determined by the document class and the packages you use. You don't have to worry about it while you're writing your document. And the other nice thing is that with this type of system, all of the numbering of all of those sections is handled automatically by LaTeX. So as you edit your document, you don't have to worry about updating all of the numbering. All of that gets taken care of automatically as soon as you recompile the document. As an extension to this structured concept of LaTeX editing also allows you to do cross-referencing between different elements of your document. So if you've ever worked on a group report or a larger project like a book or a journal article, you probably know that sometimes you end up with lots of things like this in your text, where either with question marks or highlighting, you have placeholder numbers that you have to go back and make sure that you update the numbers as things get moved around the document for section numbers, figure numbers, table numbers, things like that. And to handle this, LaTeX has a label and reference system that attaches to each of the counters for, say, a section counter or a subsection counter, even an equation number, or later on when we get to figures and tables. And the command for this in LaTeX is the label command. So if I start typing label, and then I can type some sort of a key name to refer to that section later on. And the label key can be anything you want, but it is a nice convention to include some information about the type of document element that you're editing. This just makes it easier for you when you're referring back to these labels later on. So again, to create a label that you can refer to later on, you use the label command. And the label command is always going to hook onto the last counter that was modified. So in this case, I put the label immediately after the section command. So this label is going to refer to this section's number. So then later on in the document, if I want to refer to that label, I can use the ref command. And you can see with Overleaf, this is a nice feature of our editor. You can autocomplete all the different labels that are present in your document. So in this case, Overleaf has detected that later on I have some labels for figures and equations, but in this case I want to refer to that section label that I just created. So I can press enter to autocomplete that. And if I recompile, you can see that that section number gets filled in automatically. And if you use a certain package in your document, this will actually allow you to click on the reference and jump right to that point in the PDF preview. So later on, if I'm reordering some sections, say I want to add a more formal introduction, if I recompile, that section numbering is going to be automatically updated to refer back to the same place where I created the label. And with Overleaf, it also allows you to collapse these section elements. So if you're editing a certain section and you just want to get everything else out of the way, this is useful. Overleaf knows the document outline elements of LaTeX, so you can collapse an entire section if you would like to. So if we move on to our next topic, which is math typesetting, you can see that I have the same thing going on here with label, and then I can refer to that equation number using the ref command. And then in the output, you can see I have equation 1, which is referring to my first equation that I created right here. So there's two different types of math typesetting in LaTeX. The first type is inline math, which is done using $signs, or there's also a slightly newer syntax with backslash parenthesis and then backslash close parenthesis. That will also do inline math. So with the $signs, that's the traditional way to use inline math, but you can do either method. So with inline math, it's always displayed in the running text, right in your body text. So this is useful for short expressions or if you're explaining a variable within a sentence. But for longer expressions or equations, typically you would use displayed math for that. And with displayed math, you can see an example here. It gets set off from the main paragraph text, and optionally it can have its own numbering system. So the most common environment for that is the equation environment. In LaTeX, as you may know, there's the concept of environments, which is anything with a begin and an end is an environment. So this is the equation environment. And within this environment, we type our math syntax and then optionally add that label so that we can refer to the number of the equation later. If you have a less important result or an intermediate result that you don't necessarily want numbered, but it should be set off on its own, for this you can use the starred equation environment. And this is a common convention for LaTeX commands and environments, is if you have the command itself, it gets a number, or the environment itself, it gets a number. But if you add a star to that environment name or a star to that command name, you will get the unnumbered variant of that. So in this case, I have an unnumbered equation because I'm using the equation star environment. One of the common packages for math typesetting that I would like to talk about is called the Ams Math Package. And you can see I've loaded that up here in my preamble of my document. This is a very common package. It's also used by a lot of other packages that you may use in LaTeX. And with the Ams Math Package, we get a lot of additional math typesetting environments. So another common task is to align a series of equations. And for that, Ams Math provides the align environment. So you can see Overleaf has some autocomplete functionality for the common environments. If I press enter, it'll fill in the rest of the environment code for me. So if I had two equations that I wanted to be displayed together, I can use the align environment for that, using a double backslash to insert a new line or a new row of an equation. And so you can see here, if I recompile, I get the two equations, but they're not really aligned yet. And the way that this works for the align environment is we use the ampersand symbol immediately before the symbol that we want to be aligned in the output. So now that I've added those, if I recompile, you can see that these multi-line equations are aligned at the equals sign. Again, because I've used the align environment, both rows get an equation number. If I switch to using the starred environment instead, I get no equation numbers. And if I wanted a mix of, say, some of the lines should have an equation number and other lines should not, I can switch the whole align environment to be numbered, and then I can use the no tag command on the row that I don't want to be numbered. So you can see here now my first row gets a number and the second row does not. So when you're first learning LaTeX math symbols, it can be overwhelming to start to learn all of the different command names. So there's a great resource online. This is not affiliated with Overleaf, but I would like to highlight it because it can be very useful. It's called Detectify. And with Detectify, what you can do is you can draw the symbol that you're trying to typeset, and it will return some possible results. So it analyzes your drawing and tries to determine what symbol you're trying to typeset. Maybe my drawing was not good enough here. Let's try another one. And the alternative to this is if you, this comes from a LaTeX resource. I'll open this up, called Symbols. And in here, it's a fairly exhaustive list of all the different symbols that are available in LaTeX. So you can see that this is almost 340 pages long. If you know the name of a symbol, you can search for it here, but if you don't know the name, it can be difficult to look through this to figure out exactly what command you need to use. I'm not sure why this is going so slowly, but usually it works great. There we go. We got some results. And at the end, I'll also talk about some Overleaf resources that we have for this as well. And like I mentioned, the Ams Math Package is very common for a lot of these items. This symbols list that I mentioned comes from a website called CTAN, which is the Comprehensive Tech Archive Network. And this is a great place to look if you are looking for LaTeX packages on a certain topic. There are lots of different topics that CTAN has organized, where you can find packages related to that topic. Or if you know the package that you're looking for, you can search for it directly. So for example, for Ams Math, you get information about the package. And this is also very useful if you want to know how to use all the features of a particular package. You can access the documentation for the package right from C10 in most cases. So in this case, this is the documentation for all the options of the Ams Math package. So that's another great resource. Okay, let's jump to our next topic, which is figures and tables. The first thing to understand with figures and tables in LaTeX is they're known as floating environments or floats. And the reason for that terminology is in traditional typesetting, larger elements like figures and tables actually get moved around the document to best fit the space on the page. So this is one thing that commonly confuses people who are new to LaTeX, because if you're used to a word processor type environment, if you insert a figure or table, it always shows up exactly where you inserted it on the page. It doesn't move around to different areas. But with LaTeX, things work a little bit differently. And so you can see already right here, I have this figures and tables section heading, and then I have a paragraph of text. Everything looks good so far. But now I have this subsection command followed by a table. But if I look at the PDF output, you can see that the table comes before that subsection. And the reason for this is that LaTeX has rules for replacing floats. And in a standard setup, the floating environments are figure and table. So for this table, the default placement is what's known as TBP, and T stands for the top of the page, B stands for the bottom of the page, and P stands for the float can go on a page that only consists of other floats. So this is the default. And so you can see in this case, it's placed the table at the top of the page. But if I modify this to override the default and say BP instead, recompile, you can see now that table has been moved to the bottom of the page. If I wanted to ensure that it would appear on a page that has no running text, only other figures and tables, I can restrict it further to only P. And now I will get the table will only appear on a page with other figures and tables. There is a third option that's not included in the default float placement specifiers, and that's known as H, which means prefer to put the float here. And that here means in the text flow where it's been written in the source code. So if I change this to H and recompile, you can see that now LaTeX is respecting my order of the text, the subsection heading, followed by the table itself. And there are other options for this float placement algorithm, but this covers the most common scenarios, are H, T, B, and P. We do have help articles on Overleaf that cover this in more detail as well. Okay, so you can see here we have this table, and this is a fairly common table that's used for illustrating different table styling commands. Let's focus on this a little bit more. If you're used to building tables in Excel or some related tool, you're used to having borders around every cell in the table. And this is fine for some purposes, but when you're presenting a table in a report or an article, it's sometimes useful to group the table information into logical sections. So instead of just putting a horizontal line everywhere, you might want to only use horizontal lines to separate different sections of the table or to highlight different relationships within the table. And then the other item is the vertical rules, which are also fairly common, don't necessarily add a lot of information. And so there is a very common package for modifying things like this, and it's known as the book tabs package. So if I go back to my preamble and load the book tabs package, jump back to my table, let's see how we can modify this to use the lines to show some information about the relationships in the table. The first thing that I want to do is remove the vertical lines. And to do that, we need to visit the way that each column of the table is defined. In LaTeX terminology, this is known as the tabular preamble. It's the first argument to the tabular environment. And those vertical lines are specified using the pipe symbol between each column. So if I go through here and remove all of those pipe symbols, I can clear out almost all the vertical rules, but you can see that I still have a vertical rule around the item cell. And that's because this item cell is a merged cell across two columns, which means that it gets its own preamble section for this multi-column command. So I also need to remember to move those pipes out of that tabular preamble as well. Okay, so now we've gotten rid of all the vertical rules. As I mentioned, the book tabs package is all about using lines in tables to establish relationships. And so book tabs has a couple commands that are different from the standard H-line command for a horizontal line. So in book tabs, we have, instead of just using a regular horizontal line at the top, we can use the top rule command. And then similarly, at the bottom of the table, instead of using the regular H-line command, we can use the bottom rule. And so you can see that the book tabs package makes the top and bottom rule a little bit heavier of a line weight to emphasize that relationship. And it also inserts a little bit of space between the table content and the rule itself. Okay, so now I have the top and bottom rule command inserted, but I also have all of these horizontal rules within the table. And sometimes these are just extra lines, but in other cases, it can actually obscure information from the table. So in this case, I have two entries under the NAT. I have a per gram price, and then I have an each price. And this horizontal rule doesn't really help me here because it's actually separating the NAT information from the different prices. So we can clean up this table by removing some of these other rules as well. And this is another nice feature of Overleaf. If you have table content or other items that are aligned column-wise in your source code, if you want to edit many lines at one time, if you hold down, I'm on a Mac right now, if you hold down the Option key, you'll see the cursor changes to a plus sign. On a Windows or Linux PC, the same thing should happen if you hold down Control. And when I'm in this special cursor mode, if I click and drag, I get a multi-line cursor. So instead of having to edit many lines at one time, I can actually edit all these lines with one keystroke. So now if I recompile, dropped out all of these extra horizontal rules. Here's another place where I can use the book tabs special commands. So instead of top rule or bottom rule, here I'm going to use mid rule, which is for a rule in the middle of the table. And you can see that book tabs has changed the spacing a little bit. Now I'm emphasizing that everything above the mid rule is the table headings, and everything below the mid rule is the table content itself. So now the last item remaining is this H line here. And really the item command, or the item cell, really refers to animal and description, not necessarily the price, because the price is common for all of the entries. So we might want to limit that horizontal line here to only a certain number of columns. And in book tabs, for that, I can use the C mid rule command, which means a mid rule that only applies to certain columns. And the mandatory argument for the mid rule command is the range of columns that that rule should apply to. So in this case, I want that mid rule to apply to columns 1 and 2 from the table. And here we have the final result then. All of these commands in book tabs are also customizable. So if you do want to learn more about how everything works and best practices for book tabs, you can check out the package documentation. I showed how to access that via CTAN, but there's also another great resource called techdoc.net. So if I type techdoc.net/pkg and then the name of the package and press enter, it's automatically going to fetch the PDF documentation for that particular package. So you can see here is the same example table that we've been working with. And the manual talks about a lot of the layout commands and logic behind those decisions. Okay, so the next common topic is the figure environment. So if I start typing begin and figure, this is another very common environment. So Overleaf will autocomplete. If I press enter, I get a typical snippet of figure code. So this is useful because this is a very common setup for a figure environment. Typically, your figures are going to be centered. So we do that with the centering command. And typically, a figure environment is going to have some graphics included in it. So it pre-populates the include graphics command for you. It also puts in a placeholder caption and a placeholder label. So if I just put in some actual information here, and recompile, you can see that now my figure gets output. Example image A is just an example graphic that's present on any LaTeX system, so it's convenient for testing projects. When you include an image, as you may know, it's included at what's known as its native size. So if you did want to change that, the include graphics command also has a lot of options available. You can customize the width or height of the image. You can rotate things if you need to. All of that can be done with the include graphics optional argument here, which comes before the required argument of the file name. So now I've decreased the size. And you'll notice here that the same thing is happening. That figure got put at the top of the page. If I wanted LaTeX to prefer that it goes right where I put it in the source code, I can override that default placement and say H. One thing I will say about the figure and table placement specifiers. If you're editing a large document, it can be best to leave this type of customization until the very end of the editing process. And the reason is, if you tweak all of these positions and then edit a lot of text higher up in the report or the article, the original place where you inserted the source code is going to move around on the page, and it might no longer make sense to prefer the here placement. It might be better to have a top placement or a full page placement. So that's why I suggest to leave these types of customizations until the very end of the editing process. Okay, so on to the next item, which is citations, bibliographies, and reference lists. This is another very nice feature of LaTeX, and Overleaf integrates with all of the functions that LaTeX is capable of. So instead of typing out your references manually and needing to manage how they're styled and how they're displayed in the document, LaTeX offers a different system that's based on the .bib file format. And lots of different online tools can export this type of a format, so it's become very common. But the basic idea is, for every reference that you want to use in your project, you have an entry in the bib file for that reference. And the entry starts out with what type of entry it is. In this case, we're looking at a book. Then you have a key, which is the string of text that's used to refer to that reference within your actual running text of your document. And then within the entry, we have all these different fields. So we have a title field that contains the title of the book. We have the author field that contains a list of the authors, and so on and so forth. But you'll notice that in this bib file, I don't have any formatting commands. I'm not saying anything about the title should be italicized or the title should be in quotes. The .bib file is meant to be separate from the style of the command. It's just the reference information that should be displayed with the reference. So what this means is you can have a bib file and use it with many different bibliography styles, and LaTeX manages the formatting of that reference list. It's just up to you to input the information that's needed. So if we go back to our document, and if I go to the end where the references would typically be entered, you can see I have this bibliography style command. And in this case, I'm using the plain bibliography style. We have lots of help resources on overleaf.com/learn that show you examples of all the standard bibliography styles that are available with LaTeX. But the bibliography style command tells LaTeX how that reference should be displayed. And then I also need to point LaTeX to my bib file. In this case, I have a bib file called references.bib. So I'm going to go to the bibliography command and point it to the references.bib file. So now if I recompile and I go to the end, you can see I have a references list. And right now, there's only one reference printed. If I go to the bib file, you can see that I have a number of references in this bib file. I actually have 4, but only one has been printed. And the reason for that is LaTeX will only print the references that you've cited. So if I go search my tex file for the cite command, you can see that I've only cited one reference, and it's this Chapra 7e. So that comes from that key that I set up in the bib file. And so it has only printed one reference. So if you have a common bib file that has a lot of entries in it, you can reuse it, and LaTeX will only print the references that you actually cited within your document. So that can be useful. And you can see here in the reference list, let me zoom in a little bit. This is reference 1 because it's the first thing I've cited, and the formatting is controlled by that bibliography style command. So you can see the title has been italicized, but I never said in my bib file that the title should be italicized. And if I go and cite a different reference, this is another nice feature of Overleaf, is it will auto-complete different reference keys. So you can see here that I have all the different reference keys that were in my bib file. I have them available to me here. And then as an additional premium feature of Overleaf, we also offer a more advanced reference search, which comes up if you press Control Space, as you see at the bottom of that autocomplete list. If I press Control Space, I can search by the author of a reference or the title or the year. This is useful if you don't necessarily remember the exact key that you used in the bib file, but you remember the author, or you remember the year that it was published, or you remember some keywords in the title. You can search for things this way. So now that I've added a reference, if I recompile, you can see that now I have 2 entries in my reference list. And if I jump to that citation, you can see that the numbering is present in the citation there. And again, depending on your package settings for your Overleaf document, a lot of times if you click on the citation, it will jump to the corresponding entry in the reference list. So to extend this with Overleaf, lots of people nowadays are using online tools like Mendeley or Zotero to help manage many references that they're going through in literature review and other reading. And Overleaf also integrates with those tools as well. So if you have your references stored in Mendeley or Zotero, if you'd like to bring them into an Overleaf project, you can click on New File. And if you have access to these features on your account, you'll see 2 entries here from Mendeley and from Zotero. When you first click on this, if you haven't already linked your account, you'll see a prompt to link to either Zotero or Mendeley. And once you've linked your account, for example, I've linked my Mendeley account, you'll have the option to import a BibTeX file from your Mendeley library. And you can choose what file name that should be in your project. It defaults to references.bib, but you can see I already have used references.bib, so I'm going to call it Mendeley references instead. So here's my original references.bib file. And here is my newly created Mendeley references.bib file. And you can see that they look a little bit different. So the reason is, with the bib file that's in the project, I can actually edit this file however I need to right in this project. But if I'm bringing in references from Mendeley or Zotero, I can't edit these files in Overleaf. I have to go to Mendeley or Zotero, enter my library, make the changes that I need to make in Mendeley or Zotero, and then refresh the file in Overleaf to bring in those latest updates. But with this system, now I have some extra references available to me. So if I wanted to add an additional bib file, I can separate it from my original references.bib with a comma and fill in my Mendeley references. So now if I wanted to cite another reference, like say Let's see, I think I had a cotton in there. Yep. Now I have references coming both from my Mendeley bib file and from my bib file that's in the Overleaf project itself. So that's a little bit more about syncing with Mendeley or Zotero using Overleaf. I would like to point out some resources that we have available. I mentioned before about mathematical symbols. We do offer a command reference card that I know when I was first learning LaTeX, these types of quick reference cards were really useful for me. I printed these out and had it next to my desk on a pegboard just so that I could refer to it. Talks about different syntax and commands for LaTeX. And then it also has a reference list of commonly used symbols. So if you've used LaTeX for a while, you probably have a lot of this memorized, but sometimes it's nice to have the reference just in case. So we offer that for LaTeX commands. And then on Overleaf itself, the Overleaf editor, we offer a number of keyboard shortcuts. So we also offer a handout to the community that lists all of these shortcuts if you'd like to print these out. You can also access information about the shortcuts direct from within Overleaf. If you open the Overleaf menu on the upper left and scroll down to show hotkeys, all of that information is also displayed right in the editor. If you do have questions or run into a question you can't solve, say you're looking for a package to do a certain thing, or you're using a package but you're not sure how to customize it in a certain way, there are some great online communities available. The two that I recommend are Tech Stack Exchange, which is a Q&A website, and there's also the latex.org community, which is more of a forum setting. And with that, either of these sites, you can ask questions and the community members will answer. These are great for if you have detailed LaTeX programming questions or customization questions. Of course, if you have problems using Overleaf itself, or you're not sure how to do something in Overleaf, you can also contact our support team, which I'm a member of, and that's accessible from our contact form on our Overleaf website. So I'll show the documentation that we offer. We have lots of guides for common tasks with LaTeX and Overleaf. And then we also have help articles on different math topics and different things that you might run into with LaTeX. But if there's something that you can't figure out how to do, you can always contact us using our help form, and we'll get back to you as soon as we can. So the most voted extra topic that we had was tips and tricks for customizing the compilation process on Overleaf. So I'll just talk about this a little bit before I jump into the tricks. So the way Overleaf works is you have your project files here on the left, and in the project menu, each project has a main file setting, and here is where you choose which is the main file that gets compiled in your project. And based on that setting, Overleaf uses a tool called Latex Make. And what that does is it runs the compiler, and it also determines if it needs to run any external tools. Like there's an external tool that gets run to produce the references information. Overleaf detects when that needs to happen automatically. For some of these other more advanced topics like indexes or glossaries, there are other external tools that need to be run. And for the most part, for most projects, Overleaf takes care of this automatically. But there are cases where you might need to customize that. And so this is where the Latex Make RC file comes from. So Latex Make is the build tool that we use, and you can customize it by using a configuration file. So there are some common scenarios in here, like for example, if I use the current time command, let me just put this in quickly. So if, say, I wanted to put a timestamp in my document, now depending on where you are in the world, this may actually be correct, but I'm in the US Central Time Zone. You can see for me right now it's 12:51 p.m., but this is displaying 5:51 p.m. And the reason is that our compile servers have their clocks set to UTC. So if you did want to customize that, there is a way, and you can just you can create a file in your Overleaf project called Latex Make RC, and then put some customized environment variables or customized commands into that file to customize how things are displayed on Overleaf. So if I create a file called Latex Make RC with no extension, and if I go here and say I want to be in the Central Time Zone, all this is doing is setting an environment variable on the compile server that's telling it, okay, I'm actually running in a different time zone. So now if I compile again, you can see that I do get the correct time zone. So that's a common customization. There are a lot of other ways that you can use this. So if you have multiple documents within an Overleaf project, say you have like a journal article and then a separate document that's supplementary information for that journal article, you can use a package called XR to enable you to create references between actually two separate documents. So in this case, I had cross-references within a document, but with XR, you can have references between two totally separate documents. And then if you are a more advanced user and you have your own custom package files, there are ways to organize them in Overleaf using the Latex Make RC file. If you wanted to use plain text or some other type of text system, a lot of times there are ways to customize Overleaf to be able to support those different tools. And a common way to do that is with the Latex Make RC file. If you were using a different glossaries package or index package, we cover most scenarios with our built-in Latex Make RC file. So we have a help article called How Does Overleaf Compile My Project? And this is our standard Latex Make RC file. So you can see we have lots of rules for different glossaries or index creating packages. So if you do need to customize the way that processing works, this is a great starting point. You can customize things with your own Latex Make RC files from this starting point. So this is what we use for a typical Overleaf project to cover all of the different scenarios. All right, so at this point, I'd like to open it up for questions the last few minutes here. If you have any questions, please enter them in the Q&A box, and we'll get to as many as we have time for. Okay, one question that we did get Is it possible to change the shortcut keystrokes? Unfortunately, at this point, it's not possible. It is something that we are looking into, but at this point, the keyboard shortcuts that are available in the hotkeys list can't be customized. One thing that I will mention is if you're used to using some plain text editors, the most common ones are Vim or Emacs. If you are well versed in either of those editors, we do have emulation for those two editors available in Overleaf. So that is one option, but the built-in hotkeys at this point can't be customized. Another question that we received is, can I put comments in the bib file? And the answer is yes. So in a bib file, anything that doesn't fit the standard entry text will be ignored. So you can put a comment. You can't use the percent symbol to enter a comment like you might be used to with a typical text file where you can enter comments with the percent symbol. That won't work in a general bib file, but you can enter text outside of the standard entry format, and that will be ignored, so it's effectively a comment. Okay, good question. So another one that came in is, a journal prescribes a certain reference style in Mendeley. So which reference style do you use while compiling in Overleaf? So this is another thing that comes up when people are switching journals, and a lot of times the journal will have a template that's available, and if you use a template for the journal, the template will pick the reference style that gets used automatically. But if you do need to change the reference style, you do that in the bibliography style command. There are some other packages for bibliographies, but the most common method would be you edit the bibliography style command to change the way the references are displayed. You should not really have to change the content in your bib file because, again, ideally, the bib file only contains the information. It doesn't contain anything about the style. Okay, what would be the best way to export output tables from statistical software packages such as Stata, R, etc.? So I'm not an expert in this. This is not my field of study, but we do integrate with a tool called RTech, which allows you to run R code on Overleaf. And I do have a fairly basic example here of that. So the basic idea is there are special keywords that get inserted into a file that has the RTech extension. And so right here we have an R chunk that begins here and ends at the @ symbol. And so everything between those two symbols gets processed as R code. So if I recompile this, you can see I get a new document that has this code and also the output from that code. So in this case, I'm generating a sequence of numbers with R, displaying a summary of statistics. And with R, there are ways to create LaTeX tables. So this could all be integrated together. We do also have some additional examples of this on our documentation. Okay, thanks everyone for all the questions. We are just about out of time, so I will close things off. If you have any questions that we did not have time to answer, we will follow up with you via email. So thanks to everyone for joining us today for our Part 3 Intro to Overleaf webinar. And again, we'll be following up with an email message tomorrow with a survey for feedback on this webinar. If you have time after I close the webinar, you can also complete the survey right now. So again, thank you all for joining us. I hope everyone is staying safe and healthy, and goodbye for now.